the received signal, and an oscilloscope to display the signal of what we see. In this case, we have a 1.6 volt received in the received transducer, and in this case, in the air-coupled system, we have a peak-to-peak signal of 1.6 volt, which is quite similar to the other one due to the fact that we are using a high sensitivity transducer. What we want to show now are the difference when we do a test using air-coupled and water-coupled transducer. So if we put an aluminum piece on the water tank, we see a decrease of the signal that it is due to the reflection that takes place at the interface between the water and the aluminum. The situation is similar if we use, for example, a methacrylate sample. And in this case, we see a much more or less decrease of the signal because the acoustic impedance of this material is closer to the impedance of the water. And we also see a ringing here in the amplitude spectrum of the signal that it is due to the establishment of some resonances within the material. The situation is completely different when we go to air-coupled transducer and air-coupled technique. If we put an aluminum sample between the two transducers, the signal completely disappears. And this is due to the huge impedance mismatch between the air and the aluminum. We have to increase the gain of the receiver until we get some signal. Now the signal is 200 millivolts. It's still large enough to take the measurement, but it is much more lower than the one we observed there. We can use this technique also for the methacrylate material, and in this case the amplitude of the signal